to be sure. So let's look at 63 through 69 odd and see if we can make sense of those. Let's just start with 63. But it starts out with this information. Assume that f is differentiable for all x. The signs of f prime are as follows. So f prime is greater than 0 up to -4. F prime is equal to 0 between -4 and 6. And f prime is greater than 0 from 6 to infinity. Supply the appropriate inequality sign for the indicated value of C. I'm first thinking I might want to just try to sketch this thing very roughly. Yes, sir?
The top F prime and the bottom F prime is supposed to be different, the greater than and less than signs.
Wait, no, but the one I did miss was this is less than. Greater than 0, less than 0, greater than 0. So I could try to sketch this. It would be very rough because I don't have very much information. But up to -4, what does this tell me about the graph of f? If f prime is greater than 0, what's f doing? F is increasing. In fact, I might even could make an extra column here. F is increasing and then decreasing and then increasing. And so I'm hesitant to sketch this because I don't really know what's going on, but I do at least know that I'm increasing up to -4. I'm decreasing until I get to -6, or excuse me, to 6, and then I'm increasing again after that. So that graph is probably not accurate, but it does reflect the signs of f prime. And so maybe a visual would help. So that information is for this whole set. 63 in particular says g of x equals f of x plus 5, and we want to know g prime of 0. Well, so if I take the derivative of all of that, that would be g prime of x equals f prime of x. The plus 5 would go away. So g prime is equal to f prime. So g prime of 0, that would be in this interval. So that would be less than 0 for 63. Yes, no? What I did was I took a derivative of both sides of this equation. And that told me that g prime was equal to f prime, because the derivative of 5 went away. So if g prime is equal to f prime, then g prime of 0 is equal to f prime of 0, which I already know f prime at 0 is less than 0, is negative. And that's all it's asking is it greater than, equal to, well, really it would just be greater than or equal to 0.
So there's really no math to it? It's just kind of looking at it and evaluating it?
Yeah, I wouldn't phrase it that way, but you're right. There's nothing, I wouldn't say there's no math. You took a derivative,
Yeah.
but it was just more of symbolic, like g prime, g to g prime, f to f prime.
Okay.
Let's do 65. G of x equals negative f of x. And we want g prime of -5. Or at least, how does that relate to 0? So we take the derivative of both sides to make g prime show up. So what's g prime equal to? Negative f prime. So g prime of -5 equals negative f prime of -5. And f prime of -5 f prime of negative 5 is positive or negative? F prime of negative 5. Let's see. Negative 5 would be in this interval. F prime is positive. So f prime of negative 5 is positive, but then that negative out front means that g prime of negative 5 is negative, so less than 0. Shall we do 67 while we're here?
Yes.
G of x equals f of x minus 10. And we want to know something about g prime of 0. So again, take the derivative of both sides. G prime of x equals, how do I take the derivative of the right-hand side? Chain rule. So outside in, the first layer is f. Derivative of f is f prime. Don't change the inside. And then what's the derivative of x minus 10? 1. So it's really, if we forgot the chain rule, we'd still be okay, since the result was 1. So g prime of 0 means plug 0 in for x equals f prime of negative 10. Then I go look at my picture up there, or well, my picture or the table, either one. F prime of negative 10 is positive, so g prime of 0 is greater than 0.
Can you explain a little bit more about how you know which one to look for? Because I'm kind of confused about that.
So like, how did I know f prime of negative 10?
Yes.
Okay. So remember, this means f prime at x equals negative 10. Or when x equals negative 10, either way. So x is negative 10, back up here on my picture. So I'm looking at, like, here's my x values. So if x is negative 10, we're in this interval. So f prime is positive.
Okay.
If I wanted to use my picture, negative 10's over here, and f prime would be positive.
Oh, okay.
So again, I didn't ever really need the picture, but if it helps you visualize what f prime is telling you, maybe it's a good idea. Plus, when you get to 69, it kind of walks you through that picture. Oh, now it uses a different one, but it's the same idea. All right, questions from 7 through 43, though. You guys jumped into the deep end with those questions, which is fine. 7 to 43 is the more normal-ish part of the assignment. Questions from there?
29.
Which one?
29.
29. Let's see. Find the critical numbers. Find the open intervals on which the function is increasing or decreasing. Find the relative extrema. Use a graphing utility to confirm your results. So, we maybe don't have to do that, but we can if we want to. So that just walks us through the whole process. So critical numbers. Okay, so here's part of your review for your test. Critical numbers, or your quiz, excuse me. Critical numbers are where f prime equals 0 or f prime is undefined. That's one of the questions on the test. This is just find the critical numbers. Don't do anything with them, just find them. And that's the first step of this question. So the derivative is 2 over 3 times the cube root of x plus 2. So f prime equals 0. That would be nowhere, because that would be where the top is 0. F prime is undefined when the bottom is 0. So I can set the bottom equal to 0 and work through the algebra steps, or hopefully you're to the point where you can look at that and tell me what value of x would make the bottom 0. Say it, Natalie. What was it? -2. So my only critical number is -2. So there's part A of the answers. Part B, find the open intervals on which the function is increasing or decreasing. So I use -2 to set up the intervals. And by the way, this part is not on the quiz today, right? Setting up intervals, increasing, decreasing, that's not on the quiz. I'll pick 0 on that side. And when I pick those numbers, where am I plugging them into? Which equation? Because I got an f and an f prime. F prime, because I want them to tell me whether f prime is positive or negative, because that will then tell me if f is increasing or decreasing. So f prime. And remember, we're okay with crazy numbers because all we care about is positives and negatives. So if I plug in -3, cube root of -1 is -1. I get negative. What does that tell me about f? F is decreasing. And again, if you want to draw the picture, you can. If I plug in 0 to f prime, 3 cube root of 2, who knows what that is, except that it's positive. So f is increasing. All of that is showing my work. To state my answer, I need to be clear. I guess I could just kind of use this. It's decreasing from -infinity to -2. And it's increasing, thank you, from -2 to infinity. So that's part B. And then part C, apply the first derivative test to identify all relative extrema. Well, the picture kind of gives it away, right? If I'm going from decreasing to increasing, then what's happening at -2? X equals -2 is a relative minimum, and then you have to say why, you have to justify, but the justify is almost always going to be the same. F prime changes from negative to positive. Negative to positive makes a minimum. It says check it on a graph. I will sketch you a graph of this. Looks something like that. So sure enough, there's a relative minimum at x equals -2. Other questions? We got time for probably one more.
Can you do like one of the ones that have like sine or cosine?
Okay. Trig functions remain your favorite, obviously. So that goes 41 and 43. How about 43, since that has sine and cosine in it, right? So f of x equals sine of x plus cosine of x. Read the directions. Consider the function on the interval 0 to 2 pi. Okay, that's good, so I don't have to go forever either direction. And then I think it's the same as the one we just did. Well, It lays it out a little differently. Find the increasing and decreasing intervals. Apply the first derivative test to find the relative extrema. Use a graphing calculator to see if your answer makes sense. So first job is critical numbers. So f prime would be cosine of x minus sine of x. And we want to know where that's 0 or undefined. Well, it's not undefined anywhere because cosine and sine are smooth, continuous, they're good. But equals 0. This one's a little bit tricky. I think I want to move the sine x over and think of it this way. Where does the sine equal the cosine? You know your unit circle well enough to know the places where the sine and cosine have exactly the same. Definitely pi over 4. Root 2 over 2, comma, root 2 over 2. Anywhere else? Yeah, same thing in the third quadrant where they're both negative. So pi over 4 and 5 pi over 4. So those are my critical points. Set up a number line. We could check 0 and pi and 2 pi. Probably easiest things to check. Checking them into what? F or F prime? F prime, because we're looking for increasing and decreasing, and F prime will tell us that. So cosine of 0 minus sine of 0. Cosine of 0 is 1. Sine of 0 is 0. So that tells us that F is increasing. If you're watching on video, they're trying to blow up the school right now, is what it feels like. So if we plug in pi, cosine of pi minus sine of pi. Let's see, cosine of pi is, I have to evaluate trig stuff while they're blasting the school. Cosine of pi is -1, sine of pi is 0. So f prime is negative, which means f is decreasing. And then 2 pi, well, 2 pi should give me the same thing as 0, but I guess we should check to make sure. Cosine 2 pi minus sine of 2 pi. 1 minus 0 is 1. F prime is positive, that means f is increasing. And now let me make sure I've answered the questions. Find the open intervals on which the function is increasing and decreasing. I sort of have that, I guess I should spell it out a little bit. Increasing from 0 to pi over 4, and 5 pi over 4 to 2 pi. And we start at 0 and stop at 2 pi because that's where it told us to start and to stop. And decreasing from pi over 4 to 5 pi over 4. Apply the first derivative test to identify all relative extrema. Well, increasing to decreasing, what's happening at pi over 4? If f prime changes from positive to negative, a relative max. Again, I didn't draw the arrows that time, maybe I should have. So relative max, relative max at x equals pi over 4, because f prime changes positive to negative, and a relative min at x equals 5 pi over 4, because f prime changes negative to positive.